So I've got some instructions that you can go through, and eventually there'll be like detailed, well, there is detailed answers below. But fundamentally, our aim is to look at the test structure of this leadership scale, and see whether the items group into the 6 scales that it's meant to measure, run a reliability analysis, and do exploratory and confirmatory factor analysis on it, do some preliminary data analyses to check the data file, univariate statistics, means and standard deviations, correlations between the scales, and then run some theoretically meaningful regressions. I mean, that's your bread and butter kind of IO psych thesis right there. You know, you've got a few scales, you've got some that are kind of predictors, you've got some outcomes like performance or job satisfaction, and you're going to check the scale properties of your scales. You're going to look at the univariate, then bivariate statistics to look at how things relate and so on, and then run some models to test some more complex relationships. Plenty more you can do in all sorts of cases, but that's kind of bread and butter. So hopefully by doing that here and then also in the assignment, that'll be useful for many use cases. Cool. Okay, so let's make this research question meaningful. The aim is to see whether transformational or transactional leadership predicts unit performance better. Or whether either predict, and if so, which one predicts better, and so on. So, yeah, okay. So we're going to do a bunch of things. We're going to run an exploratory factor analysis, confirmatory factor analysis, and reliability analysis on the scales. Then look at descriptive statistics and correlations, and then regressions. Cool. Okay, so it would take me a fair bit of time to run through this all from scratch. So I'm going to kind of show you the here's what I prepared earlier version, if that makes sense. But the answers will provide fairly extensive steps. So essentially, I've used project template to create a folder structure. And here it is. And I've renamed the project and the folder. And so we have this report. There was a few initial steps that I've done here. In particular, the raw data files that came from the internet that had these data files were tab delimited. So I've done a little cleanup, merged the 2 data files, and got them ready for you, so you can incorporate them in. And I've put those data files in the data folder. So you've got some file called MLQ, and also some metadata. So MLQs, the items on the 360 test, and also the outcome measures. And the metadata tells you how to score the 6 scales of the 360 instrument. So you've got the 6 scales and also just each of the items. All right. So if we load this project, it will load automatically the MLQ metadata and the data file called meta.mlq. Actually, maybe I'll clear that and just pretend like I haven't run this munge step. And so we could check that everything imported well by doing things like head MLQ and check, oh, that's the first few rows of the data file. You've got all the items, or they're kind of parcels of items, so these are different scales of the 360 instrument. And these details are all described in the notes to this. Oops. And then you've got a range of other files. And yeah, we could check the dimension of the data file to check that it all looks good. So there's 1,059 cases, that's good, and so on. Okay. We could also do some cleaning to check on missing data and so on, but I'll skip that step. Okay, so if we wanted to do an exploratory factor analysis, so for the assignment, you'd be looking at Big Five and checking that. For this case, we're doing, we've got 6 proposed factors for the MLQ. And so there's a function called scree-plot. That should show us the scree-plot. So what's this telling us, this scree-plot? Does anyone have a suggestion? Yeah, I mean, so this is each of the components, and then on the y-axis we've got the size of the eigenvalue. How would people interpret that? How many factors do you think it's telling us? Or what's it telling us? Yeah, I think like the Cattell rule or whatever it is about the flick, it's sort of, there's definitely one big global factor, and this is what I always say about 360 instruments. Although there are these subscales, the biggest and most important thing is people have an opinion about whether their boss is good or bad. And that's the big thing, and then there's all these other little things. And you can repetition the variance to say, oh, there's this subscale and that subscale, and there is nuance, but there's also, so there's one big global factor, definitely a second or third, something meaningful, and then it's a bit harder to say. Has anyone ever run a parallel test before or come across it at any point? No? So this is a more sophisticated approach to assessing the number of factors that compares the eigenvalues to random data. So if the eigenvalues are larger than random data, then that suggests maybe that factor or component is meaningful. Interestingly, we are actually getting 6 factors here, but if you do it as principal components analysis, only 3. So it's a little bit confusing. My suggestion would be that there's probably something meaningful at these lower levels, going down to 6 factors potentially, but the main story is the global factor and maybe a second or third one. Anyway. Okay, we can do a factor analysis with 6 factors, like this. And you know, we can have a look at the loadings. And we can see that when we extract 6 factors, the items are largely grouping into the factors we've suggested. So MBA 1 to 3 is loading on factor 4, MBP is loading onto factor 3, contingent reward is loading on factor 2, and so on. There's a couple of anomalies, but not too bad. So yeah, it's not too bad would be the conclusion of the EFA. One thing I wanted to quickly show you. Okay, so you're doing a thesis. You've got this, but you want to get it into your journal article or your thesis or whatever. This is how you would do it typically in R. You would write the loadings or the table to a file like this. Okay. Then we would start to bring it into something. So we've got the loadings here. Here they are. But you want to get it into a format that's pretty for your thesis. So what I typically do is I have a little Excel file where I put everything. And the idea would be, you know, you do your number formats. So maybe this is quite nice. 0.00. So the numbers are looking a bit nicer already. Maybe we'll center them. Maybe not, I don't know. We could go ahead and bold the big ones. That might make it look nicer, maybe above 0.3. If you know a macro for doing this automatically, then even better, but I don't know one off the top of my head. So yeah, we could go around and double check it that it's looking all good. Let me know if I've missed one. You could possibly put the item text if you had actual items. Maybe add some bars. I can't see the bars, they're hiding. I'll have to do it this way. And so on. I mean, none of this is terribly exciting. What have I made? Oops. No, this is terribly exciting or complex, but this is just, I just wanted to go through one example where you export the CSV, you open it in Excel, and then you do the pretty up, and then you paste it into Word, and probably Times New Roman, add your tables and stuff, and yeah, etc. You've got a table. Nothing special, but yeah, that's kind of the general, well, it's one workflow that if you're not going to do full R Markdown reproducible, that's kind of how you would do it. You export the CSV, open it in Excel, and do a bit of that, and then paste it into Word. All right, so that's exploratory factor analysis. What about confirmatory factor analysis? So this is using the lavaan tool. So I've added this package to my project template, so that's why it's able to use it. And it's fairly easy. It's a fairly straightforward notation for writing up your models. So this model 3 here describes a 6-factor model where we've got the factor name, and then it's loading on, or the items, IC1, IC2, IC3 is loading on the factor. And there's lots of good helps files that describe this process. Just for comparison, I've fit 2 other models. One is the global factor model. It says that all items load on one factor, and another is a transformation and transactional model. You can fit it with the CFA function, and then we could get a summary of the model like that. So that's the third model. So the standardized solution will give us our standardized loadings. And we can see things like, oh yes, the items appear to be loading above 0.6, 0.7 pretty well. That's good, good items. We can also see somewhere down here the correlations between the factors. So they're about 0.3, 0.4, 0.7. Some of them are negative. So there's some, as we might expect, some fairly large intercorrelations between these 360 measures. And this last little bit just gives us the fit indices for the 3 models. So this is the kind of maybe table you might want to produce. So we can see model 1 was the 1-factor model, model 2's transactional transformational, and model 3's a 6-factor model. Rules of thumb for CFI, only model 3 was good, and even RMSEA is not that great for model 3, but it's terrible for the other 2. So how do we reconcile this? I said before, it looked like a 1-factor model was pretty damn good, or explained most of the variance, yet here it's clearly saying if we want a hope of good fits, we want a 6-factor model. How would you reconcile that? What we saw with the EFA saying maybe 1, or possibly there's a little 2nd and 3rd factor, versus this saying 6 factors a minimum. So model 3 is the 6-factor model. Model 1 is the 1-factor model. And model 2 is a 2-factor model with transformational and transactional. So yeah, if you look at the CFI, rules of thumb are like at least above 0.9, ideally above 0.95. So we're only getting 0.93 here for model 3. Yeah. So I guess my message would be there's often a tension between CFA prioritizes getting every little nuance of the data represented. And so to do that, maybe you do need 6 factors or even more. To capture most of what's important, you could probably get it with 1, but you won't get all the little nuances. So that was the CFA, suggesting that a 6-factor model is at least reasonable. What if we wanted to get a reliability analysis for our scales? The score items function from the psych package is really good at doing that. The main thing is you just need to sort out your scoring key. That's the hardest bit. So I've prepared that earlier, so to speak. So essentially we've got these 6 scales for the 6 tests, and they have 1s because there's no reversed items for each of the columns that things belong to. So we've got the keys there, which is just all the 1s and stuff. I've created a few variable sets to make life easier. So they're the 6 MLQ scales and so on. And then this is the actual data. So I've saved that to an object called scored. And scored has a bunch of things in it, including, if you didn't know it was there, you could go like that, alpha. It's not so nice when you see 6 decimal places, so let's round it to 2. And that's our Cronbach's alpha for the 6 scales. So, do they look good, bad? Not sure. I'm actually not sure. Like in my world, I live and breathe Cronbach's alpha. So like I go, oh yeah, above 0.8, pretty good. Above 0.7, yeah, it's okay. So pretty good. Yeah, but they're the rules of thumb that you have in your mind. I'm not sure. That's definitely a rule of thumb worth remembering. If reliability is above 0.8, that's pretty good. Above 0.7, reviewers are probably not going to complain. Yeah. When you start getting down to 0.6 and 0.5, then yeah, you're going to have issues. We've looked at the scale. It's reliable. 6 factors seems like, well, they're quite correlated. Maybe it's a bit of overkill, but if we want a nuanced representation of the scales, it's pretty good. Okay, so how do we produce one of those nice tables of, where you get the means, the standard deviations, and the intercorrelations? How can we get one of those things with R? So what I'm going to do is I'm going to extract the elements of, a descriptive statistics and correlation matrix. I'm going to store the elements in a list. First, I'm going to get the correlations. And I must confess that the first time I ran this, I got missing data down here because there was some missing data on the goals data. About 50 people didn't have data for goals. So that's when I had to go back here and say, okay, who's got missing data? And let's just, for simplicity, let's just get rid of those 50 people. Anyway, I've done that already. So we've got the correlations. And this sapply thing will give us the mean of each variable, and same this for the SD. And so I can assemble a data frame with the means, the standard deviations, and the correlations. So that looks a bit like that. Lots of details. Probably nice if we round it. And then we could repeat the process like I showed before. Let's export it to CSV and then, do something in here. So we can make it nice and easy to interpret. So for the correlations, we probably want to do that little trick of number formatting. Do people know the rule about when you go 0.00 and when you do 0.00? That's it, yeah. If a number can be greater than 1 or less than -1, you don't omit the leading 0. So even if you had, for example, oops, not that, that's a bad example. Yeah, so correlations cannot be larger than 1 or smaller than -1, so you do like that. Whereas here, a common introductory mistake is to go, oh, that looks like a number I should go, blah, blah. But that's not APA style, at least. Because in theory, a standard deviation could be 10 or 20 or 30. So yeah, we could pretty this up, etc. There's all sorts of things here. You could probably put the scale names, obviously, and oops. You could use numbers, maybe. That might be nice. So often see that, maybe with dots. Oops. Maybe, like this kind of thing, just nice and tight. Oops, too tight. Etc. Yeah, and then add your line borders and blah, blah, blah. So that's kind of a workflow anyway. In terms of interpretation, we can see what's correlating with what internally. So we can see that there's some big correlations between, yeah, anyway, these are the kind of scales. We have to double check, but so essentially, it's telling us that certain subscales, in particular, it seems like there's a clustering around these three, I think, or maybe there's a few more. What is it? Attributed charisma, intellectual stimulation, and individualized consideration. So I guess that's transformational leadership. It's quite highly intercorrelated. And this MBEP, passive management by exception, which I imagine is something like only kind of interact with your employees when they stuff up. That's negatively correlated with all the other leadership scales. We also see the pattern of correlations with unit goal performance, so around 0.2 to 0.3 for all of them, although passive management by exception is negative. So that's informative, that perceptions of leadership are correlated with perceptions of unit performance. Then we might want to finally stretch up to the level of some regression models. And so these are the three transactional scales, and these are the three transformationals. So this is how we run a regression. We use the LM, or linear model, and it has a fairly simple notation: DV, outcome measure, predicted by, with this little tilde, a shift in that character next to the 1. Then you have each of your predictors with a plus, and then the data set. So yeah, I've ran 3 models, one with the transactional predictors, one with the transformational, and one with all 6. I've saved it in a list, so I can do this little lapply thing, which will return the fits for each of these models. So you've got the coefficients and the adjusted R-squared and so on. So this is just returning the adjusted R-squared for each of the models. And it's telling us that the transactional explains 16%, transformational 12, and all of them 16. So if anything, it's looking like transactional is predicting better, which is kind of interesting. And we can also compare models. So then transactional to the all model. So adding transformational did not significantly improve it, and adding the transactional to the transformational did improve the model. So there's more details about all this in the notes, but we can look at the coefficients for that final model, and we can see that the main significant predictors was MBEP and MEA. So we have that negative passive management by exception and positive prediction for management, active management by exception, whatever that is. So my instinct is that possibly all the positively scaled items are highly intercorrelated. And if we actually look back here, it seems like probably most of these positive variables are predicting in a similar way. And then possibly the management by exception is adding some additional information over and above that global positive evaluation. So So yeah, I'm not sure how insightful the data is, other than to say that you want to ask questions not only about whether this is a good leader, but also perhaps ask questions about whether someone's a bad leader. And maybe together that kind of model predicts unit performance better. Overall, what we've done here is, I guess, a complete set of analyses that would, in theory, be a thesis. You know, we've gone through the scale properties, we've looked at correlations and descriptive stats, and then we've tested some models, and then the main task is then to relate it back to theory. This exercise is downloadable from the regression one. It's called the Van Berg exercise. There's detailed notes about how to work through each step.